Okay, today we're doing the last tab in our foldable and we're doing the second part of it. And this is on Unit 15 circles. Yesterday we talked about sectors and circles. Today we're going to go ahead and talk about tangent lines and circles, so this will be the last part of the notes for the foldable. Okay, this is our first of 5 slides and that we're doing in this part of the foldable. Again, if you run out of room, you can write on the back, but there's about 5 slides. And try to make your pictures smaller because each one of them have a picture. But in general, a tangent line is a line that touches a circle in just one point. So right now, this tangent line, AB, that's right here, which I'll draw, touches the circle at exactly one point, which is right there. And what you know about a tangent line is when it touches a circle at one point, and it touches particularly the radius, which I'll draw in green here, okay, whenever it touches the radius at exactly one point, it's perpendicular to that. So it ends up forming right angles there. And that's going to be real important on what we do today. Types of tangent lines that can occur, there's really just 2 types that occur when you have 2 circles. This first one right here, which I'll mark with the little red asterisk, okay, you have a tangent line that touches each circle at one point right here and here. And they would call that a common internal tangent line. The word internal means inside. Notice how it kind of touches at one point on the inside. And then the other type, which I'll mark in blue over here, is considered an external tangent line. But again, notice how it's a tangent line because it touches at one point, but it is on the outside. It doesn't go in the inside of the circles. It's on the outside, and that's what the word external means. When you have 2 tangent lines that come from a point outside of the circle and meet each other, okay, so we can see it's tangent here and here, and it's tangent to the radius. Okay, that's why you have the 90-degree angles. But when they come out and they intersect at a point which is here, notice how the 2 line segments are equal to each other, which are marked here. So we're going to use that in some of the stuff we're doing. We're going to do 2 examples in a minute, and then you're going to have a question after each example. So you're only going to have 2 questions today. So make sure you pay attention on the 2 examples that we do. Okay, here's our first example. We have a circle. We have a line that is tangent to it because, again, it touches at our first point right here. So what you know is when it's tangent to the radius of the circle, we know the radius is this line right here. What it ends up making is a right angle. Okay, I have a right angle. So what this tells me is I actually have a right triangle that gets formed. Okay, right triangle. And we've solved this many, many times. I want you to solve for x. I have a right triangle. So you should use Pythagorean theorem. So remember, you have a squared plus b squared is c squared. C is always the number across from the hypotenuse, which is right here in this problem. So here's what I have. I have a squared plus b squared equals c squared. And if you type that in your calculator, 15 squared is 225. Okay, 17 squared is 289. Okay, if you type that in. So I'll subtract 225 on both sides. I figure out x squared equals, and I subtract that, I believe I get 64. So if you remember to get rid of the squared part, you would take the square root of both sides, okay, and you would have x equals 8. And if you did not get a whole number, then you would just simplify the radical if you had to type it in. This problem will not go in your notes. This is the first problem you're going to do that you're going to answer. So go ahead, pause this, and go ahead and answer this problem, and then you'll move on to the last slide of our notes. Okay, this is the last slide of our notes that we're going to take, and then again you'll have one other question you're going to do today. So we learned in the other slide that when you have 2 lines that are tangent at a point on a circle, which these 2 are, and they intersect or meet each other on the outside of the circle like these 2 do, and what you know about these sides is they are congruent to each other. So if I want to solve for x, I know those sides are equal to each other, so I'll just set each thing equal to each other. So I know that since both sides are equal, I know 2x plus 10 has to be equal to the other side, which is 3x plus 7. Okay, so I'm going to set them equal to each other, and I'm going to solve for x. So remember, when you solve for x in an equation like that, you move all of your x's to one side, all of your numbers the other. So I'm going to go ahead and subtract 2x on both sides, okay, but it doesn't matter which side you move them to. Okay, when I do that, 3x minus 2x's is 1x. And then I'll simply move this 7 to the other side, so I'll subtract 7 on both sides. And so what you figure out is x ends up being 3. And you can fill that in, and if you fill in 3 into both sides, you should get the same answer. If I fill in 3 right here, 2 times 3 is 6, 6 plus 10 is 16. If I fill in 3 here, 3 times 3 is 9, and 9 plus 7 is 16. So you would get the same answer. Okay, here's your second question. Go ahead and find the value of y. Again, this is similar to the one we just did, but go ahead and pause the problem and then find the value of y.